Assalamualaikum warahmatullahi taala wabarakatuh, and greeting to all of the panels. My name is Wan Muhammad Zuhilmi bin Zulkifli from Faculty of Mechanical Engineering and currently in semester 7. So here I will present about my final year project's proposal, which is the title is Energy Harnessing for Street Light using Piezoelectric. So the introduction for this project is we know that energy is a fundamental for our daily life. Based on thermodynamic first law, we know that energy cannot be created nor destroyed. It only can be modified from one form to another form. So energy, we know that energy consists of two type of energy, which is renewable and non-renewable. So for this project, it's focused on the non-renewable energy, which can be alternative for for the renewable energy that will depleted soon. So the aim of this project is to harness the kinetic energy from vehicle passing through the proposed street section of the road. So the road proposed for this project is a road in Korean in Perak. So first thing first, what is a piezoelectric? A piezoelectric is a material that can convert a mechanical force exerted on to electrical energy. So the amount of pressure applied on the piezo is directly proportional to the amount of energy generated. Many researchers have proven that the capability of this piezoelectric technology may exploit as a renewable energy source of electrical energy. So for the problem statement of this project, so we know that Malaysia continues to strive for future development. The natural resources that are required for the ongoing demand for energy begins depleting in Malaysia. So here, a piezoelectric crystals can produce electrical energy when the crystal is deformed. It's called the direct piezoelectric effect. This concept can be implemented on the road by implanting the crystal on a platform on the road pavement for lighting up the street lights. So the objectives for this project is first to develop an appropriate system integration of piezoelectric generator that can be used to power up street lights on the road. Second is to maximize the harnessing characteristic of electrical energy from piezoelectric generator by capturing the wasted energy produced on the road. The significance of study for this project is the minimization of energy costs for the use of street lights on the roads, and also consider the most suitable size of the designated area, number of piezoelectric generator needed, and the frequency of vehicle passing through the area. So the scope of study and limitation for this project is first to focus on the system integration of the piezoelectric. A set of piezoelectric crystal will be implanted in a base and placed on the road with area of 75 meters square. So the generated electrical energy will be stored in a battery and will power up two LED street lights in the night time for 10 hours per day. And then during the 14 hours of the daytime, it will be used to harness the electrical energy to be stored back into the storage battery. But the limitation for this project is first, lack of expertise related to the piezoelectric crystal, and then actual data may cause the result to be different from the estimation calculated in this project. So harnessing the kinetic energy, how this energy will be harnessed is kinetic energy will be generated from a car moving through the set of piezoelectric implanted on the road and convert it to an electrical energy using a suitable system integration. The methodology for this project is first build a mathematical model for the system integration and then develop a suitable system integration for the piezoelectric generator and then determine the design specification of the system. Next, build a proof of concept model for the system and then do a result validation based on the proof of concept. So this is the mathematical model that is present in a block diagram. First, from the piezoelectric generator, and then move to the voltage regulator, move to power supply circuit, and then power supply circuit will move to transformer, and transformer will send signal to comparator, and then from the comparator, it will receive signal from battery and transformer, and then send the signal to a logic gate. And then this is the control system to prevent battery from overcharge. And then from the battery, the energy of the electric will send to the LED to light up the street light. Then converting the kinetic energy to electrical energy. So when vehicle pass through the piezoelectric crystal, mechanical stress will be produced, and which in turn will generate an alternating current voltage. And experimental data shows that applying 80 gram force of the tip of the crystal at a frequency of 60 Hz will produce an open circuit voltage of 15 volt peaks between the two electric leads. A 15-volt amount of voltage can easily charge a 12-volt battery used in this project. So this is the system integration for the piezoelectric generator. First, a Zener diode will be used as a voltage regulator to control voltage spikes that might arise because of large vehicle that may pass through the piezoelectric generator. And the voltage regulator is also to provide a constant output voltage to a load that connected in a parallel connection. And then Zener diode will maintain a constant output voltage till the diode current falls below the minimum current value needed. And then move to the power supply circuit. This is a circuit of the power supply. So a power supply consists of full bridge rectifier, which will convert the alternating current to direct current voltage. And then multiple capacitor is used to smoothen out the pulsating direct current into a constant direct current power. An IC 7805 voltage regulator is used for regulation purpose. The IC is used as a precautionary measure to avoid circuit from damage. So how do we store the energy harnessed from the piezoelectric? Battery lead acid type rechargeable battery, 12 volts with rating of 200 ampere hour is used for storing the energy. This battery is made of 6 galvanic cells in series to provide a 12 volt output for the usage of the street light. So this type of battery rating will be able to discharge a constant power of approximately 240 watt hour in 10 hours, which will be enough to supply power to the street lights. So protection for the battery is a comparator will be used for this purpose. A comparator has two inputs from the transformer, and the other is from the battery. So this is the logic gate for the comparator. The logic gate will send signal to the battery, which is whether the battery need to be charged or need to be off charge. So this will prevent the battery from being overcharged. And this is the automation circuit. Automation circuit will use LDR, light dependent resistor, to sense the light. The LED will turn off during daytime as the resistance of LDR drop, causing the transistor Q to turn off. And then during nighttime, resistance of LDR will increase, and this will cause the transistor Q1 turn off, and then simultaneously we turn on the transistor Q2. This will cause the LED turn on. So this is the expected result from the project. The velocity of vehicle passing through the road is about 60 km per hour based on the speed limit in Malaysia in urban area. And then the average weight of vehicle is about 1,650 kilogram based on the research article found. And the coefficient of rolling friction is also taken from the article found during the research, and the length of the piezo is 0.5, which is the diameter of the piezoelectric used for this project. And then the outcome of this expected result is about 8.7263 times times 10 to the power of negative 3 watt hour. So this value is the value of electrical energy that can be generated from a piezoelectric generator. So discussion is opportunity for research to conduct a more detailed research on this performance of piezoelectric crystal in harvesting the energy. And then the piezoelectric can also be used to harvest energy from shows or floor touch. This shows the another kind of way of harvesting the energy from the piezoelectric. But the findings may be inefficient as there are other factors that we not considered in this project, which is first shape of the piezoelectric and then the actuator of the piezoelectric. So as a conclusion, as a developing country, Malaysia could implement this kind of system to save costs and energy usage for the modern technology and also able to avoid pollution in our country. And then the capabilities of a piezoelectric has provide an alternative method for harvesting energy, which will give the opportunity for those who are in difficult area of getting the electricity from the power grid may exploit this alternative. So that's all the presentation about my final year project's proposal. Thank you very much and much thanks to all of the panels. Assalamualaikum warahmatullahi wabarakatuh.